Hello everyone, let's solve some Leetcode today. So today we have Leetcode 125, that is valid palindrome. In this problem we will be given a word and we have to tell whether this word is a palindrome or not. So what is palindrome? Well, it is simply a word. In this word, if you read it from left to right, it will be same as if you read it from right to left. For example, we have a word called noon. So if you read from left to right, we will see N-O-O-N. If you read from right to left, we will still see N-O-O-N. So it is noon from this side and again noon from this side. We have other words also. For example, race car. So if you read it from left to right, you will get R-A-C-E, C-A-R. If you read it from right to left, you will again get R-A-C-E, C-A-R. So if you are reading from left to right or if you are reading from right to left, it is basically creating the same word. That is what a palindrome is. So now let us try to understand how we can find whether a particular word is a palindrome or not. So one simple way is to simply reverse this word. You will have another word that will be a reverse of this one, and then you will simply compare the two strings. If both of them are same, you will know that you have found a palindrome. But let's be honest, that is first of all order of n, and you are actually running 2 or 3 loops. So what if you want to actually do this in a one pass loop? That is, you want to just run one single loop and you want to find out whether the given string is a palindrome or not. So in order to check whether this particular string is actually a palindrome or not, let us try to understand why we were using 2 loops in the earlier approach. Well, one loop was used to reverse the string. And after reversing, we again run the second loop to compare the two strings. So it means we just have to find out the workaround for one of these 2 points and we will have a single pass loop solution. We cannot have a workaround for this, right? We need to compare whether this actually reads left to right and right to left same or not. So it means we can try to find the workaround for reversing the string. So why do we need to reverse the string? Well, if we reverse the string, we will actually get this particular element at the starting, right? And then what we are trying to do is we are trying to compare this string and then this string, right? So we will try to compare this element with this element. But then again, this particular element is actually nothing more than this one, right? So what we are trying to do in the grand scheme of things is we are trying to compare the starting element or starting alphabet with the ending alphabet of the word. If they are same, we continue. Then again, in the reverse string, we will have A here again. Then we will compare this A with this A. What we are doing is that we are simply comparing this one with this A. And if they are same, we again continue. We will then have this C here. Then we will compare this C with this C. What we are doing here also is just we are comparing this one with this one. That's all. If they are same, we continue. Then we have E. We will compare this E with this E. What we are doing is that we are basically comparing this E with the same E. Why? Because there is no other word. And that's exactly what we are really doing, right? Now, of course, we will have a C again, A again and R again. And then for this C, what we are actually doing is that we are taking the second half of the string, that is this C, we are comparing it with this C. But this C is actually nothing more than this one, we just writing it here. So what we are doing is that we are again making a comparison between these two. We don't need to make a comparison, right? Because we have already made the comparison. The same will be going for this A and this A. We are again making a comparison. Then for this R and this R, we are again making a comparison. So what this means is that I don't really need this particular reverse string. I just need the access of these elements from these two directions. So how can we do that? Well, we will simply use 2 pointers. So we will have a pointer on this index, that is 0, 1, 2, 3, 4, 5 and 6. So we will have a pointer on 0, then we will have a pointer on 6. We will check, are the elements at these 2 pointers same? If they are same, we will simply decrement this pointer to index 5 and we will increment this pointer to index 1. P1 is now 1 and P2 is now 5. We will check again, are these two same? Well, they are same. So we will again simply increment this one. P1 will be on 2 index and decrement this one. Now P2 is at index 4. Now we will check, are these same? Well, they are same. So we will simply increment this one again. Now P1 is here. And we will decrement this one here. Now P2 is here. And so they are basically pointing at the same index, that is 3. So we will perform the check again. The element at P1 is basically equal to element at P2 because they are same. So we will simply decrement this one. Now P2 will be here and we will increment this one. So P1 will actually be here. Now P1 is greater than P2. So P1 is at index 4 and P2 is at index 2. So P1 is greater than P2. It means that we have covered the entire string. So we can stop the loop and we can just return the result. That we can definitely do. We can start from the end and we can go till the middle and we can just return the result. Now this is one way of doing it. There is another way also. we can also start from the middle. So we have P1 here and we have P2 here. We compare, is the element at P1 equal to P2? Yes, it is equal. They are basically pointing to same element. So now we can decrement one of the pointer and increment one of the pointer. So I will decrement P1. Now P1 will be here and I will increment P2. So P2 will be here. Now we check, is the element at P1 equal to P2? Well, yes, it is. So we again decrement P1 to here. P1 will actually be at A and P2 will be at this A. Now we check, is the element or alphabet same? Yes, A is equal to same. Then again we actually decrement P1 to this place and then we decrement P2 to this place. And then we check, is this alphabet equal to this alphabet? Well, it is same. So yes, we again decrement P1 to here and we increment P2 to here. Now as you can see that P2 is now out of bounds. So the index of P2 at this point is 7 and the index of P1 is actually -1. So they are both out of bounds. So we will simply end the loop at this point. Now both of these tricks are useful. The starting from middle is really useful when you are solving medium problems, because if you try to solve medium problems with this one, you will end up with a two-dimensional dynamic programming solution. And of course that will be harder to implement. So in a lot of cases we simply use this approach starting from the middle because it makes the solution simpler. But it does not mean that starting from end is actually bad, because that is useful in its own way. In the current question that we are solving, it is already written that we can get a dirty string. A dirty string is a string in which we can get non-alphanumeric like hashtags, dollar, right? All these kind of things. We can also get spaces, like multiple spaces. We can get dots. These are not alphanumeric characters, right? And we still have to figure out whether the given string is a palindrome or not. Of course, these alphanumeric characters are not part of the palindrome, or they are not considered part of the string if you are trying to find whether it is palindrome or not. So in case you see these characters, you are supposed to kind of ignore them. And so it means if you try to solve this question with this approach starting from middle, you will need to clean the string. You will have to take all the alphabets and put them into a string or into an array in a lowercase way. So you will have a clean string that will only contain alphanumeric characters like alphabets. But if you actually use this way, you can get away without actually creating any extra space. So you can go through string by end and you will be able to solve it. Let us see how both of these approaches will work. So now we have the same example again. It's just that we have a few alphanumeric characters here. We have this comma, we have this spaces. Okay, these are representing spaces. They are not underscores right now, but I'm just representing spaces with these. So we have comma, spaces. How are we going to tell whether this string is palindrome or not? Because it is a palindrome, we already saw in the above examples. It's just that we have a few extra characters which are not alphanumeric. So we can do the same thing again. We can have P1 at index 0 and P2 at index 9, and we will check R is equal. Well, yes, R is equal to R. So we will simply decrement this one. The P2 is at A and increment this pointer. So P1 is at A. Now we check this one. So yes, they are also equal. Again, increment this, then decrement this. Then again, they are same, correct? Then again, increment the P1 and then we again decrement the P2. Now as you can see that P2 is actually at a non-alphanumeric character, that is space. So we will keep on decrementing P2 until it actually reaches a character that is actually an alphanumeric character. Alphanumeric characters are simply alphabets and numbers. So I will decrement P2 again and I will decrement P2 again. And since comma is not an alphanumeric character, I will decrement P2 again. So now P2 is at this point, right? And I find that P2 is now at alphanumeric E. So now we can make a comparison. So is the element at P2 is equal to the element at P1? Well, they are both the same element, so yes, they are equal, and that's why we will return true. I mean, you will of course decrement P2 to this place and increment P1 to the next one. So P1 will be here, but as you can see that P1 is now greater than P2, so you can simply close the loop. So if you start from the end, you can see that you don't actually have to change the given input in any way. You can simply put a few extra conditions that will keep incrementing or decrementing the pointer until the pointer reaches an alphanumeric character like an alphabet or a number. So you did not actually had to modify the input, and you did not actually had to create a new array either. So now let us look at the another approach. So here we are going to start from the middle. Here we have how many elements? We have 0 to 8. That means we have 9 elements or 9 characters. So the middle of this particular thing is going to be divided by 2. It is going to be 4. So the integer division of 9 by 2 is going to be 4, not 4.5, because we are taking the integer division, not the decimal one. So it means 4 is going to be considered as the middle point, right? So we will have our P1 and P2 at this point. Now we check what is this particular character. Is this alphanumeric or not? Well, this is not alphanumeric, right? So we will simply decrement the P2 and suppose P2 come here, and we will increment the P1 and the P1 will be here. And so P1 is actually at a space now. This is representing space, not underscore right now, but we are representing space with this one. So P1 is at space and P2 is at E. So E is definitely an alphanumeric character. So P2 is fine, but P1 is at space. So we need to increment it again by 1. So P1 is now here. And now you can see that we are at alphanumeric characters. So P1 is at C and P2 is at E. We will check, are they same? Well, they are not same. E is not equal to C. So we will simply return false. But we have already seen in the above example that this particular thing, race and car put together, they make a palindrome. They are a perfectly valid palindrome. So what happened here? Why did it actually return false? And the reason is bad calculation of center. So here the center is actually at 4, right? Calculation wise, you are correct. But this 4 does not really represent the center of the palindrome word. When we only had race, car, without any non-alphanumeric characters, we had indexes like this: 0, 1, 2, 3, 4, 5, and 6. The middle here is what? 3, right? Index 3 is the middle, and that's why we could actually go from here and here and here and here and here. Like in this direction we could go, in this direction we could go, because we were starting from the true middle of the palindrome word. But here what you are starting with is a false middle. This is not a proper middle. This is the middle of the string, not the middle of the palindrome, and that is why we end up returning false, even though this string is actually a palindrome. So does that mean middle approach will not work in this case? Well, yeah, kind of. In this kind of strings, middle approach will be very, very, very difficult to implement. So what you will actually have to do is you will have to create a new array or a new string, and you will store all these things inside of it. So you will store R, A, C, E, C-A-R in that array or in that string. So basically we will have to remove comma and spaces, all of the non-alphanumeric characters, and we will have to take the R-A-C-E and the C-A-R and then simply put that together into a string or in an array, and then start with the middle of that array or string. And so of course this is going to take a space complexity of order of n, because you may end up storing all of the characters into the array, because we don't know whether the given characters are alphanumeric or not. Maybe everything is just alphanumeric. We don't have commas or underscore or spaces here. So in the worst case, this array or string will end up storing all of the characters from the given string, resulting in order of n space complexity. So in this approach, you are basically taking the string and creating a cleaned version of that string into an array or another string. And now we can decide which approach we want to go for. Well, since this particular approach is very useful when you want to solve question in the medium category or hard category, we are going to use this particular approach, that is starting from the middle and code it up. So now let's go through the code. First of all, I have this cleaned array or a list. Since I'm using Python, I will call it list. So in this cleaned list, I will store all the alphanumeric characters, that is all the alphabets and all the numbers. So here I'm running a for loop on the given string s. So s is the input, and I'm taking each character from that input, and I'm checking whether the given character is alphanumeric or not. So if the given character is alphanumeric, I will simply append that character into the cleaned array. I will append a lowercase version of that character, because we don't need to worry about uppercase or lowercase. So we will just simply make everything lowercase, and then I will append the character into the cleaned list. So in this way, I will take all the alphanumeric characters from the given string and I will place them into the cleaned array. Now here I'm checking whether the cleaned array actually contains even number of elements or odd number of elements, and that actually makes a difference. For example, suppose you had a word like noon. Here we have 4 characters, right? If we try to find the middle of it, so 4 divided by 2 is equal to 2, right? So indices are 0, 1, 2, 3. So this will be considered as middle. So if we try to place P1 here and P2 here, then yes, P1 and P2 are same or equal. In this case, we will decrement P1 or P2. So I'm decrementing P1 here and I'm incrementing P2 here, and then we can see that O is not equal to n, so we will end up returning false. But we don't want to do that, right? Here also we are actually getting into the same problem. The center calculation is actually wrong. The center is not 2 actually. The center is 1 and 2 both. What it means is that we need to place pointers in the starting condition on 1 and 2, not on just 2. So it means P1 will be here and P2 will be here. We will check, are these equal? Well, yes, they are equal. We will decrement the P1 here and we will increment the P1 here, and then we will check, is n equal to n? Yes, we will increment this P2, we will decrement this P1, and now we are at out of bound indices. So we will simply stop the loop and return true. So what we are doing here is that we are calculating the middle, 4 divided by 2, that is 2, and we are placing a pointer that is P2 on 2, and then we are placing another pointer not on P2, but we are placing it at P2 minus 1 so that we will cover both of these elements in case we have even number of elements. So that is exactly what we are checking here. We are checking is the given number of elements odd. If they are odd, we don't actually have to do anything. But if they are even, we have to do something, right? So we are starting with P1 and P2 at the middle. That is, we are taking the length of the cleaned array and we are dividing it by 2 for both of the P1 and P2. And here is the magic. So if the given string is actually odd, we will not do anything. But if it is not odd, we will actually have to decrement P1 by 1 so that our center calculation will be proper. And here we are simply starting our algorithm. If we ever find that the element at P1 and P2 are not equal, we directly return false because at this point it is very clear that it's not a palindrome. Otherwise, we decrement P1 by 1 and increment P2 by 1. And if this entire while loop runs without any problem, without returning false, we know that the given string is palindrome. So at the end, we will simply return true. So now let us run it and see what happens. So our solution runs in 11 milliseconds and beats 35.91% of the solutions on Leetcode. If we would have used the other approach starting from the end, our solution would be a lot more efficient, but understanding the current approach will help you in many different questions in the future. And of course, our solution is passing all the 487 test cases. So now let us look at the space and time complexity for finding the palindrome. So for the approach 1, where we were starting from the end of the strings, we had pointer P1 at 0 and pointer P2 at n. That is the end of the string. The time complexity at that case was order of n because we were going through the string only once. We were going through each and every element in the string only once, and so the time complexity would be linear, so it means it is order of n. And the space complexity will be simply constant. Why? Because we are not really creating any cleaned array or cleaned string. We are not consuming any extra space. Yes, we do have pointer P1 and pointer P2, but they do not scale if the input scales. So it doesn't matter how big the n is, the number of characters in the string, the P1 and P2 will actually take the same amount of space all the time for each and every case, every time. So it means that space they take is actually fixed and does not depend on the given input, and which means it is simply constant. And that's why it is order of 1. Now when we talk about the approach that we are currently using, that is starting from the middle, the time complexity is still order of n because we are going through each and every element in the array or string only once. But the space complexity in this case is order of n because we are using array to actually get the cleaned version of the given string. And this array may actually end up containing n elements in the worst scenario, because in the worst scenario, every element in the given string will be simply an alphanumeric element, so we will end up storing all of it in the array. So yeah, like the video, subscribe to the channel. If you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, then just let me know in the comments. Now we will meet in the next video. Till then, bye.